Everyone. Thank you for attending KEPWARE Quick Knowledge webinar. This is organized by KEPWARE and Allied Solutions, the master distributor of KEPWARE. We are also very happy that we have two of our technology partners, Stratus and Omron, as our speaker today and tomorrow. There will be two sessions today and tomorrow, each 2 hours from 10 a.m. to 12 p.m. So if you all have any questions, right, you all can go to the Q&A chat box to type in your question, and then we will answer it, or we will get back to you. Let me go through the agenda. So day one agenda, first we will briefly introduce Allied Solutions and KEPWARE with a demo on how to link KEPWARE to PLC. Then we'll touch on securing data with OPC UA. We will also demo some network deployment scenarios of OPC UA. Lastly, we'll talk about high availability deployment of KEPWARE with Stratus. So this is today's agenda. And for day two agenda, we will have a brief opening for attendees who have missed day one. Then we'll move on to talk about KEPWARE Edge and implementing IoT solutions with KEPWARE. There will also be a demonstration on KEPWARE Edge and KEPWARE to Azure IoT. And to end this session, we are very happy to have our last exciting session by our friend from Omron, talking about some ready solutions with KEPWARE. Just very brief about Allied Solutions in case there are some attendees here that do not know who we are. We are the master distributor for KEPWARE in this region for about more than 20 years. Our headquarters is in Singapore with offices around Asia. We focus in providing automation system, industrial manufacturing software, industrial cybersecurity, fault tolerance and high availability platform for software solutions, as well as industrial networking products. And our solution and services is being deployed in all types of industry. We have a wide spectrum of domain knowledge to provide the right products and solutions to our customer. Okay, now let's move on to the main part of it, KEPWARE. Just a bit of KEPWARE history. KEPWARE was established in 1995 and is currently the top company in industrial connectivity platform. So you see that there is this KEPSERVEREX. We always use KEPSERVEREX. KEPSERVEREX is KEPWARE flagship product and is currently the industrial leading provider for access connectivity in the market. So if you look at this diagram here, KEPWARE from the southbound, KEPWARE offer a library of about 150 plus device driver, client drivers, and advanced plugin for connectivity to top PLC vendors. We cover almost 90% of PLC brands out there. And some of the other industrial initiatives like MT Connect, DMP3, IEC 61580 or 60870, or to the building management system like protocols like BACnet. And on the northbound, it provides access to client application like ERP, manufacturing execution system, HMI, SCADA, via OPC and proprietary protocols, as well as IoT visualization analysis platform through MQTT, REST, and other IT-centric protocols. Now, let me show you this diagram with give you a very good illustration of what KEPWARE KEPSERVEREX does. in the overall picture. So you could see that in the center, we have the KEPWARE EX server. It can be run as a redundant pair. And from the bottom, you can see all the device or controller or equipment that you could see in your plant floor or in the building. So we have protocols that talk to PLCs, DCS, and RTU. We also have specialty drivers that talk to different meters. In the building management, which BACnet is very common. Protocols like BACnet, we support that as well. And if you have the weighing scale, RFID, barcode reader, you could use KEPWARE UConn driver to connect to it. And some of the network equipment that you like to monitor as well, we have the SNMP suite to bring in the data. And we support all the OPC standard, OPC DA, OPC UA, ANE, and HDA. And we could bring the data to SCADA software, MES software, ERP software, or we also have a dedicated database, ODBC compliance database driver to communicate, to bring data to different databases as well. And we support different big data platform through REST or MQTT, or we also have dedicated driver for ThingWorx as well as Splunk big data platform. And if you want secure tunneling, we have a good solution through the OPC UA as well that you could see on the right-hand side to pass data to remote sites, securely pass data to remote sites. So in summary, companies normally need to overcome server communication challenge present in their manufacturing environment or automation environments using many different brands of drivers from different companies in order to gain access to different industrial data and to pass data from the equipment to the different software within the plant. So now what KEPWARE does for you is KEPWARE can serve as a single platform for collecting, aggregating, and provide secure access to the plant industrial data. So that will reduce a lot in the maintenance side of it, and you just need to have a single platform to support your whole deployment. Okay, so you could download the KEPWARE demo software from the KEPWARE website. There is a every time you download and try it, it's a 2 hours demo system. If you restart, you can continue running for 2 hours. If you need a longer time for you to try out the software, you could always approach us. Just send us an email and we can arrange for a 30 days trial license for you and to assist you in the POC or trial or that you like to work on. Okay, with that, I would pass on to my colleague here, Steve from KEPWARE, to do some demonstration on the linking to the PLC and talking about the OPC UA. Hey, Steve. Let me stop share.
Hello, can you hear me?
Yes, we can.
Okay. Hello everyone, I'm Steve. So I'm actually the Senior Applications Engineer with KEPWARE, and I'm here today to talk to you about the OPC UA architecture and introduction to how KEPSERVEREX, which is KEPWARE, fits into the UA kind of architecture and system designs. Just as a quick reminder, if you have questions to ask us, use the Q&A panel, because I have my colleague Jason, who is based in China, with me managing the back end for questions and answers. So please use that, and we will get back to you. And the materials that we're sending out today will be actually sent out later to you as well as a handout. So don't worry about that. There will also be a recording that will be coming out after we clear it with marketing and things like that. We'll upload it to YouTube, and we'll share that link across to the participants. So this will be my rough agenda for today. So you can see it's mainly on OPC UA. So I'm going to just focus on that, and we'll do with a couple of demos. So first one, we'll do a UA connection using a third-party software to KEPWARE, and then the second one will be using KEPWARE to connect to another KEPWARE, and pretty much that's about it. So for those who are not familiar with OPC, right? So KEPWARE has been known as an OPC server for the past, I guess, 10 to 20 years since we started. So if you're a current user of KEPWARE, you will be familiar with these terms and things like that. But for those who are not familiar with it, OPC is actually based on a client-server architecture. So in your drivers, in the world of drivers and industrial devices, it will be master and slave model. So the master is actually similar to client, and the slave is similar to server, in conceptual wise. So OPC is the same thing. When we talk about OPC, there is a client side and a server side. So as an example, if let's say you're a system integrator today, and somebody come over to you and say that we have OPC UA, we want you to connect. The first thing you need to know is whether when they say whatever they have OPC UA, is it a server or is it a client? Because if they are providing a server interface, you need to provide a client interface. And if they are providing the client interface, you need to provide the server interface, right? So vice versa. So on a more technical term, the client will always be the one that initiates the communication. So the client starts the server and controls the sampling rate and things like that, right? Typically, that's what the client will do. What it really means is that if there's nothing connected to the server itself will not do anything, right? So this is one of the important behavior that I think everyone who deals with OPC needs to know. If there's no client, the server does nothing. No driver, no communication, no handshake. Right, and it is the client that determines how fast the data is being pulled, not the server. So you can actually use the UA clients to kind of describe how fast you want the data, how fast at the driver layer, how fast you want to pull the device and things like that. So that's being done by the client side, right? So the whole purpose of OPC UA, right, is to provide a single, secure, reliable cross-platform framework to access, our typical industrial automation requirement. So if for those who are familiar with the classic OPC or OPC DA, the specifications were designed, but they were kind of siloed because, for example, the DA connection will not be able to work with HDA, and HDA will not be able to work with AE, and AE won't be able to work with DA, and so forth, right? They have different versions of silos of OPC that was purpose designed for various applications, right? So the idea of having OPC UA is somewhat similar, right? The idea is that you will have at the lower layer an abstraction of services that allows you to kind of share a common method, common transport, common lower layers, and then at the data information model, that will be the area where we differentiate from other, go into specialization on how the data is being described and modeled and designed for consumption. So that's the whole idea of OPC UA. Is they're trying to unify it, which is why we call the unified architecture, right? So the next key thing about this is that in the traditional classic OPC DA, they are not firewall friendly. Like if you are using the firewall, things like that, or antivirus, right? It will be very challenging to do OPC remote connection, because the key thing is that for OPC classic, they are based off the RPC calls. So what is actually happen, right, is that when you initiate a OPC remote connection, it will do a port 135 connection to the other side of things, and then it will get itself back a high port which is randomly assigned. And that's the key problem where it becomes firewall unfriendly, because the ports that are written for that connection session is actually randomly assigned across the high port. So you know, if you're using a firewall, you need to open a pretty big port number, port range, right? Typically 40K to 60K. So it's just, you know, there's no point of putting a firewall if, let's say, you are going to open such a huge range of port access. So that's not something that the DA, the classic OPC handled very well. And what happens is that in the UA design, they actually spec in to make it internet ready, which means that it will only communicate through a designated port, and that makes it firewall friendly. On top of that, there's actually a bunch of other key features that makes OPC UA great for tunneling, which we will describe later on. So for those who are familiar with OPC, there's actually two kinds, or rather three kinds of transport mechanism. There's the TCP, binary TCP, which is very likely what you will see in the market, you know. And there's SOAP, less common, but you know, sometimes it happens. And HTTP over TCP, right? So you can actually design, the specification allows for different kind of transport mechanism, but what you generally will see is the binary over TCP. So this is a slide deck which we actually compare the OPC classic protocol to, say, the UA connection. In OPC DA, right, you can see that this is, as I mentioned, the different so-called the specifications of the DA classic model. So there's DA, which is what I think most of us are using if you're in system integrator, right? So OPC DA. AE will be alarm and events. So the alarm and events is typically used, from what I can see, is DCS. So if you go into DCS, you know, you go to marine sector, you will see a bunch of OPC alarm and events. But out of that, you know, in manufacturing, you probably won't see it. And really that's because in the market, typically the alarm and events portion is handled by the SCADA side, right? When you deploy your SCADA, you will buy the alarm and event alarm module and then use that the software side. So what happens is that the software will then grab the raw data through DA and then process the alarms in its internal platform and things like that. So that's pretty much what it is. HDA will be historical data. So that's actually designed more for historians. So for those who are familiar with historian, you know, like G historian, you know, Wonderware historian, OSI Pi, they are primarily running on HDA because that's the only one that allows you to kind of it was purpose built for you know, browsing a historian, and allows you to see like range of data and things like that. So that's what HDA is for. The XML DA is actually kind of the first attempt to make a web-friendly version of DA. So you know, they actually adapt it to XML. You won't really see it in the market, at least from my perspective. We have not seen it so far. You know, only in windmills, right? So pretty much each of these information model, they are static and unchangeable. That's the key thing. They're unchangeable. DA is DA, AE is AE, HDA is HDA. You can't do anything to it. Right. So in OPC, right, there's always the few metadata that you will always have, or the properties of it. So name, quality, value, and timestamp. Right. In OPC Classic, client and servers are written for each of the individual spec. Right. So meaning that the services that you use to call out DA data, you cannot use the same method to call the AE or HDA or XML DA and things like that. That's not possible. Right. So the key thing about UA, as I mentioned, is because of all that, you know, like it's actually pretty ugly to look at when you look at from the technical perspective. So from the UA side, what they have done is that they unified it. The base services are unified. So you can see that on top of the base services, that's where when we move into the information model, we start to differentiate between the different data modeling. So previously, if you recall, the services are unique and they are unique to each of the data model type. So now they actually standardize that layer. So you can actually use a UA call to call a UA server for a certain kind of data, and they will revert with the necessary information model. So that information model can be DA, can be AC, can be HA, and it can be extended to fit various industry requirements. So depending on the industries, OPC UA Foundation OPC Foundation has actually talked to various industries to kind of tie down to what they need, and based on that, they have designed like a couple of purpose-built data types or data model, and they fit it in. So it's extensible, right? Extensible. Right. On top of that, you can also add in more information about the vendors. For example, who is the owner of this UA server, and who designed it, and things like that. So these are all enriching the core data of what can be passed on through OPC UA. So in a lot of situations where we go into talks about like Industry 4.0, OPC UA is actually one of the designated ones, or rather the ideal ones, and you can see that they're actually talking about all this data modeling on the factory floor. So rather than when you connect to a PLC and you only get like symbolic data, now you can actually get more richer information about it. For example, the capabilities of the OPC UA server, who created it, what machine is this, and in the machine what are those data points and things like that. So that can be provided with the UA, the OPC UA protocol. So in a very broad, very broad sense, this is what we have in comparison of the classic DA and UA. So for classic DA, you can see that most of the, so we're very big. Let's be specific about this. When we talk about this, we're comparing OPC UA with DA data information model. So when we compare, that version and this version, they are actually similar in the sense that most of the features are common. However, if you look at the security portion, the security portion for DA is only on DCOM only, right? And for UA, right, that is no longer dependent on DCOM. So what this means is that the DA can be actually built onto, platforms like Linux or anything like that, because they no longer depend on the DCOM component. So DCOM is actually part of the Windows component that is used by software to kind of to launch and to activate and things like that. So those are managed typically in the Windows world by DCOM, and OPC UA moves away from that, right? On top of that, the UA protocol allows you to do encryption, so you can actually protect your payload in transit, and they also support the use of certificates, X549 certs. So what that means is that if you have a pair of a client and server, you actually can have an identity check before you begin the connection. So you can validate whether the UA server that you're connecting to is it a real UA server, or is it somebody is trying to do like a man in the middle kind of connection to you. So those are some of the nice things that were built into the UA side of things, right? Then on top of that, we have the remote access stuff. So because of the encryption and the signing and the firewall friendly feature, UA allows you to actually securely transport data across the WAN. So that's really one of the key things for UA right now, because if you think about it, we're going towards IoT, and data security is very important, right? So that's like the core of the thing. So so the previous portion, we generally are just doing a brief introduction of the OPC UA protocol. So for what that means, or what that translates to KEPSERVER, right, or KEPWARE, right, is that in KEPWARE we have both the server and client interface, right? And the UA server interface comes built in since version 5, if I'm not wrong. So that's a pretty old version of KEPWARE, up till today version 6. So all KEPSERVEREX comes built in with the UA server interface. Now, what that means to you, right, is that today, if you are already using KEPWARE, for example, you are using the Modbus driver, the Siemens driver, connecting to some devices. If you're going through KEPWARE, right, immediately your data is actually UA ready. So if you're doing some sort of like aggregation or project or that kind of thing, it will be very straightforward, because you can actually just go in and take the data, right? Yeah. So for the UA client, on the other hand, is used to pull data from UA servers. So that could be things like PLCs, right? In the current market trend, you can see that a lot of the vendors are actually producing UA ready PLCs, and they market them as Industry 4.0. So for tomorrow, if you are joining us, we have Omron with us, which will be showcasing the NX series, which comes with that UA model built in. And you can see that we because of that, right, you can actually have a richer range of information coming in from the PLC rather than just your IO mapping and symbolic addresses and things like that. So that can be entirely handled through the UA client and the UA server on the PLC itself, as long as the vendor designed that to do that. So yeah, so with that, we can actually connect a bunch of stuff. So we can do things like UA client to a KEPSERVEREX to share data across KEPWARE. You can have a third-party UA client to connect to a KEPSERVEREX. So talking about that, we have also things like the new SCADA, which comes with OPC UA, right? The next gen SCADA, you can see them, they're coming in there with like UA default. So those can actually connect to us directly. Okay, so for KEPWARE, right, just to be clear, we now support only the data access model, which is the DA information model. The AEHA and the other models are currently not added to us yet. However, we have plans to support them in the near future, as long as the market starts to move into that. For now, because there's really no other software out there that has AE or HA, so there's nothing to build and test against it. So we don't have anything yet. But as long as if you're familiar with KEPWARE, the way we work is that as long as there is a market demand for software like that, and it comes to a certain point, we will then build in and build a driver against it and support that product in the future. All right. For our OPC UA, our transport mechanism is the binary TCP, right? So it's actually the highest performance one, but some of you may see situations where they require the SOAP or HTTP, but we don't do that yet. Then in terms of security, we support, I think we're pretty on parity with all the required security policy. So for those who are familiar and are already using UA right now with encryption and security, the basic 128 and basic 256 is no longer considered secure. So I will recommend you to do an update and change it to the 256 instead, right? Just to share. In fact, let me show you later. Okay, so we're going straight into the demo. Let me just take a quick look at the oh, I can see. But if you have any question right now, please go ahead and type in the Q&A panel so that maybe my colleague will get back to you. But what I'm going to do now is that I'm going to do a quick demo. So the first demo that I'm going to do is a connection using a third-party UA client into KEPSERVEREX and drivers. Okay, so to orientate you, what I have with me right now is KEPSERVER. So I have two KEPWARE, one on the left and one on the right. So don't be confused. So what I'm going to do now is I am going to launch a UA Expert, which is a third-party UA client. Right, so I'm going to start with a third-party UA client to connect to KEPWARE's OPC UA server interface and show you that how the connection is being done. Okay, so over the right side is the UA Expert, and over the left I have a KEP server running right now. And in fact, they are actually connected to a actual device. So I'm going to just roll out my webcam right now. So this is a live system, right? So you can see that it's connected through this VM, and I have the Mitsubishi, the DL05 over here, and we have the Modbus for the sensor over there, which is a blinding white light, right? So just to show you that it's a real one, I will just launch the quick client. So the quick client, again, is this small little box here that you can use to launch and read and write the data. So it's designed for you to quickly take a look at the data and do some testing, and that's it. So we have here the quick client. We can actually see that we have a bunch of text going on. So you can see the DL5, right? We can see the light. So you can actually see this small light here. So actually, if we write and change some of that, you will also blink, but it's a bit too small. So I'll use the other one. So I have a Modbus based sensor over here. It's actually a Raspberry Pi. So we can actually write the data to it. So you can see that if I write something, right, the color will actually change. See that it's now yellow. So these are all being hooked up and connected right now to so it's an actual system. So what we're going to do now is that suppose I have a third-party UA. For example, you're a system integrator, right? And then you have a case where you are required to connect to do a UA connection to a few device. Maybe it's a Modbus device or whatever it is. And that device itself typically don't come with the UA interface. So what you can do is that you can put in a copy of KEPWARE and do a UA connection. So again, I refer to the PowerPoint. What you're actually doing, right? You can actually convert the traditional industrial protocol to become a UA ready with a copy of KEPSERVER, right? So now what we're going to do right now is do a UA connection. So I'm going to just add in, and we can actually browse the UA endpoint. Right, you can then select the proper security policies to go in. So what I'm going to do now, I'm going to do a non-security policy, no security access to the connection. And then what I'm doing is I'm just connect it. And you can see that the data will then be connected. And then once you pull the data over here, we will actually subscribe to the different calls. Right, and then you can actually see the different data. So you can see that the KEPWARE implementation of the UA is pretty straightforward, right? You can see. So what we're doing now is that we are using a third-party client connected to the KEPWARE on the left through a OPC UA connection. And similarly, once you do that, you can actually write into it. So for example, I can write 3, right? And then you can see that the color change again is blue. And if you look at the local node or local KEPWARE, right, the value has also changed, right? So you can read and write and do things like that across using UA. So if you ever enter to a project, you need to so it's very typical. For example, when customer wants to start doing IoT and they want to aggregate data, so that's where you will use you may need to perform a UA connection to a device, or even in situations where your factory floor is starting to implement OPC UA. So that's where you can actually look into how to do a UA connection, and it's going to look like similar to something that I've just shown you right now. All right, so I'm going to move on to the next demo, which is the structured data type. So in 6.9, which is the latest version of KEPWARE, we have added the structured data type support for OPC UA. So on the list over here on the bullet points, right? So over here, right, these are the supported structured data types that we have now added into our UA client driver. If you are KEPWARE UA client user today, you can actually just do a simple upgrade as long as your support maintenance is in place, and you can start to use all this if you need to. If you don't need to, you can leave it. Nothing will happen to the KEPWARE. You won't die or anything. So just leave it. But if let's say you come to a situation where you were specifically asked to extract structured data type from OPC UA, be aware that in 6.9 onwards, that's where we added the support for that. Right, these are the standard structured data types defined in the OPC specification. And typically, the machine that you will see are from the Euromap machines that support OPC UA. And they are, I think, Euromap 77, if I am not wrong, right? So this, you actually see things like that. So that's some of the things that we added on to the OPC UA stuff in 6.9, right? And these are some of the other bug fixes that we have. So I won't go too deep into it. Right. So what I'm going to do now is I'm going to show you how that connection looks like using the KEPWARE's UA client driver. Okay. So going back to our demo, just now we already saw that we have used the third-party UA client to connect to a KEPWARE, right? So what I'm going to show you right now, right, is I'm going to show you Let me just disconnect first because I'm going to do some changes. Okay, I'm going to show you the UA connection using the UA client driver to another UA server. So what I have here is actually just a simple coded UA instance, right, that I've done on my side. I'm going to just move down, right? So it's a custom one. And what we have done is that what we can do is that we can actually connect to it using the UA client driver. So just go over here and select the OPC UA client driver, right? And then I can call it anything, OPC UA, for example. And change the port number. So my port number was designated at 19. And security policy, again, for the purpose of demo, I'm going to just do it none. So if you're wondering why I'm using none, right, it's because that if you choose any of the security method over here, you will need to do a two-way handshake, which is a little bit, disruptive to the demo. So I'm going to do it none. But if you are interested in that, reach out to my partners, Allied Solution, to find out more. And then you can see that these are pretty much the standard parameter of the UA client. So if you're doing authenticated connection, you can actually use this to do that. For now, we're going to just leave it blank, and that will connect through as anonymous login. Anonymous meaning that the UA server will just let you in without knowing who is this. So over here, we can then create the device, and at step number 7, you will be able to do the import, which is now. Okay, so over here, when you look at the UA servers, right, you can actually see a bunch of stuff. So this is a common complex object that was defined in OPC UA that allows you to check on what is the capabilities of the UA server that you're connecting to, right? So always take a look at that if you have to, if you can, to just kind of figure out how many how many tags that you can subscribe to, how many calls you can do, and things like that. Then if you need more information, you can call out the rest of the things that you want to see. But for the purpose of the demo, we won't do that because I'm going to just show you the structured data type, right? In fact, let me show you the arrays as well and the other data types. I'm going to just add everything in. Okay, so when you selected the text that you want, the UA client driver will actually automatically create the text for you, right? So if you're wondering what are all these things, right? If you just do a quick Google of KEPWARE UA client driver, and look at the manual. I believe at page 20. Whoa. Ooh, too much. Yes. So you can see that in page 24, right, you will be able to see the UA data types that the UA client of KEPWARE supports. So if you scroll down, you can see there are all the different types of data. So what I've actually done is that I've actually just, I've renamed it and then match number one. Number 1 is Boolean, number 2 is SBY, and things so forth. So you can scroll all the way down. These are the standard built-in atomic data type. And then if you continue to scroll down, you will see the supported structured data type, right, which is actually using the extension object in OPC UA. Right. So these are all the data type that we support right now. So if you're a system integrator, when you're connecting to something and you want to use KEPWARE, make sure to validate that the data type that is existing on the UA server is supported by the UA client, right? So typically that's found in the documentation for KEPWARE is at page 24 and 25, right? So if I launch it, boom. Right, you can see these are all the different examples of the data type. So Boolean, character, things like that. And then if we look at the structured data type, these are only available in 6.9. Okay, so this is the structured data type, and this is how it looks like. for now, we actually break it into string. And then what we do is that we flatten that data structure and we send it out to you in this format, right? So that the SCADA can actually take it and then they can actually do something about it, right? Then if you are wondering if we do array, so we also do array as well, right? As long as the array is an array of the supported built-in data type, you can actually read the array. So for example, Boolean, right? Boolean is included in the UA type. So an array of Boolean will be supported. So similarly to float and string and so forth, right? So yeah, so pretty much that's how we connect to a local another UA server using KEPWARE's UA client, right? So UA clients, right? So that's pretty much this portion of the demo. So you can see we actually connected to a remote UA device using the client. So we can actually pull back. So on top of the UA server interface, we also have a UA client driver. Right. Then we have the last demo, which is the UA tunneling. Right. So what the UA tunneling really does is that we have two computers and we want to pull data across the firewall, internet, and things like that. So typically what you do, you will have a UA server and a UA client on both sides. And then what we'll do is that we'll pull the data across. So this is the specific use of the UA client driver. And what we are going to do in this demo, right, is we are going to do a UA client, a KEPWARE to KEPWARE connection. And really why you want to do this, right, is it could be a simple reason such that, for example, today you have a requirement to aggregate various data and into a standard SCADA software, right? And that SCADA software today don't support OPC or don't support any of the protocol. As long as they don't support OPC UA, you are stuck, right? So what you can do is that you can use the UA client driver to pull data across various KEPWARE or other third-party UA servers. And once you get it in, right, because KEPWARE have other interfaces besides OPC. So for example, if you're using the IoT gateway, you can use REST call. If you're doing MQTT, you can also use MQTT. If you're SNMP, we have an SNMP agent. So we have a lot of different interface that it's not just the UA stuff. So if you are using a third-party software that are not UA ready, you can do the UA tunneling, right? That's typically the use case. The other thing is that you could be using things like iFix today, and they're still using the OPC DA stuff. So you can actually use the KEP server to kind of pull in and aggregate and then expose that data out again via the classic OPC. So you can reuse your classic OPC software and all that licensing and things like that. Things that you're familiar with, you don't have to relearn everything. So that's what I'm going to do now. So if you look at my screen right now, just now we were using the UA expert, right? So I'm going to just close it now. So what I'm going to do now is I'm going to use another UA client from another KEPWARE. So this is one KEPWARE, this is one KEPWARE. I'm going to use the UA client on this KEPWARE to connect to the other KEPWARE. And how that is done, right, is that first thing you need to do is that you need to come over here and right click on the administrator and go under the UA config. Then once in the UA config, you will see a different endpoint. By default, right, the UA endpoint, right, are disabled, right? Except I think they're all disabled. So when they're disabled, you will see that it's going to look gray out like that, right? So make sure that your endpoint is added and created. So I'm going to just show you again how it looks like. It's going to bind to all the different NIC cards, right? Then, as I was saying, if you're using any of these security policies right now, right, I will recommend you to do an upgrade and change it to the 256.256 one, because that's actually being depreciated. You can see that we write it very big, depreciated, do not use, right? Because it's considered insecure. So try not to go there. Then on top of that, maybe I'll just take the opportunity to talk a little bit on our UA interface. You can actually see that the UA certs are all over here. So these are the client certs. So when you do a trusted connection, there will be a client exchange, which I think we can actually do it for this part of the demo. right? Then we can also add in discovery server. So in UA, there's a mechanism for you to create a discovery server, and then you can use that to expose the other internal UA connection. But I don't have a UA server with me, so I'm not going to do the demo. Trusted server will be the server endpoint. And this is the part where we hold the different certificates of the UA server and client, right? So these certificates are actually created and generated by KEPWARE, right, during the installation. Just be very aware on the validity of the certificate. So you can see that this certificate only goes until 2023. So when 2023 comes, you probably will need to either reissue the certificate, which is this button over here, or you may manage your certificates through a third-party vendor by yourself, right? So that's typically the recommended method. If you, but you know, I understand from most of the industrial users out there, they wouldn't do that, so they'll just use the one that KEPWARE has. That's fine. Just be aware of your validity, right? So it's only 3 years, which is the industry standard, by the way. It's not that we anyhow say it's 3 years. We just follow the industry best practice. So in fact, so I'm going to do a trusted connection right now using the KEPWARE over here. So I'm going to use OPC UA again. Right, OPC UA, but this time I'm going to do trust with security. So this is the part where you will need to key in the URL. So the URL again, just to share, is over here. When you enable the endpoint, there will be a endpoint URL, and typically that is actually the what you call that, the IP address. So I'm going to just type in the IP address, right? In fact, if you want, you can also click this this button, and you can use the discovery URL, refresh, just to make sure that you can see it. So I'm going to do the authenticated method right now, which you can see just now. Remember on the earlier demo, we actually did the no security model, right? So if you look at the UA server, we did none, right? So no security. So it was pretty fast, right? So I'm going to do the other version, which is the signed and encrypted version, right? So okay, continue to be anonymous. Okay, then what we'll do now is that we will just finish it. Right. Oh, let me just restart my runtime. Oh, in case you're wondering why it says ThinkWorks KEPWARE server, it's because on the right side is the subscription version of KEPWARE. On the left side is the perpetual version of KEPWARE. So I'm just doing, both. They're essentially the same thing. The icon change maybe. So now I'm going to just start to do the browsing. If you recall, it's actually the same step as step number 7. You will see this part. And when I click select import, you will fail by right. You can see that it's not responding because it's trying to do the whole shit. And later on, when we come over here, oh, I gotta trust the server first. You can see that the connection will fail, right? And if you look at the events log, right, you will see that they will actually say something like the socket failed, and they don't allow you to connect to it. Oops. So I'm just create this device first. And I'm going to do that again. Oh. Socket failure. Oh, the IP is wrong. Wait, let me just double check. Why did they change the IP? 88.56. So this is the part where we trust the server cert. So again, remember the whole two-way handshake. So we gotta trust each other. So now you can see that there's only one cert, right? Which is the pretty much the KEPWARE on the right side. And the moment I trust it, I will trust the KEPWARE on the left side. And you can see that I now have his certificate. So this certificate belongs to this guy. Okay. And then when I try to browse it, you'll see that they will fail because the certificate is invalid. So once the right side trusted the left side must also trust the right side. So if you go under the UA, under trusted client, the big red cross, you got to right click and trust it. See that? So now that we trust it, we will then be able to browse it. So that's the two-way shake that we're talking about. Boom. And I can dump everything in. So you can see that I'm pretty much taking all the data over to the left side, pulling into the right side. And then you can, operate on the right side using your preferred interface. So you can see that we have like the DA stuff. You can launch it. You can use your SCADA to then draw on this guy instead, right? Or it could be a simple reason where some of the field devices have certain limitations on how many UA connection they can do. So you can use a single copy of KEPWARE to aggregate everything and then manage it from there. Right, so that's pretty much the UA connection demo, right? So in this demo, right, this particular demo, right, we are doing one KEPWARE to another KEPWARE, right, using the UA client again, and now we're doing it using the trusted and secure method. Okay, so for those who are keen to try out for yourself, just get copy of KEPWARE, or you can do what I do, have a VM running and just follow this guide. This again, the PDF will be sent out to you. Just follow the link and you will be able to do whatever I just did quickly to pull in the data. All right. So it looks like I still have a bit of time. I'm going to do one last demo for everybody. So remember that when we talk about the UA connection, we are actually doing an anonymous login, meaning there's no username and password. So what you can actually do is that there is a way to do a multi-tenant model. For example, you want to have user A who is able to see only part of the text and user B seeing another part of the text, right? So that's very typical in data center where, they have a tenant build model and then the vendor has multiple customers to send to, but they don't want to buy multiple KEPWARE, So you can actually use the user manager as an OPC UA to do this. So in the user manager, what you can do is that you can create a group, right? Let's call this group A, I guess. No, OPC user group, UA group, right? And you can actually add user into it. So let's say I call this user A. Okay, and I am going to just have the password right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because you need 14 characters. Okay, I'm going to just use this password here. So now I have a user A. And for those who are not aware, for version 6, we have the security policies built into KEPWARE, and it comes free of charge. If you are on version 5, however, you have to buy that plugin. So that plugin is chargeable in version 5, and it's now free in version 6. So what you can actually do, right, is that you can actually designate the different permission for the different users to the tag level. So I'm going to just click apply first. Oops. Whoa. is happening. Okay. Yeah. So over here, and then you can designate the permissions that you can have for this particular group. So if you go under the user manager, you can actually choose the different permissions that they have. So you can let them either, like have able to edit, able to do anything to the channel or the device and everything. So by default, everything is, blocked. So that will be something that you need to, manually designate. And then what you can do is that you can just click it, allow it, and then so this is on the group level, and that is on a tag level, right? So just to show you, for example, you can actually do, maybe say this user can only read this PLC and cannot read Mitsubishi, so you just deny him this and only allow him this. So when that user connects using the provided username and password, right, he will gain whatever permission you designate for him. So as an example, how to do that, right, is just to go under the device and the UA server, and under the authentication, you can then type user A. Sorry, that's the password. So let's just try this like this. So when the connection starts from this guy to this guy, he will then be authenticated as the user A, right? And then they will be given the different permissions that you set to. So if each of the UA client, you can designate different kind of permission, and they will be able to see different things based on the permission segregation done on the UA side, right? And if you're an enterprise user, only in the enterprise offering of KEPWARE, you can actually see that our UA user manager can be integrated together with Active Domain. So I'm going to just do one now. Let me remove this guy, right? So you can see I can actually add an AD user and just click it here, and then you can type in the object. Click apply, and that will be integrated into your Active Domain. But that is only available in the enterprise offering of KEPWARE. In the normal user case, you probably will not see that thing. Yeah, so I think I've come to the end of my session. I'm going to just stop sharing screen, and I will take a quick look at the chat box just to see if anybody. Okay, so my colleague is handling all the questions. So yeah, so if you have any questions on that, feel free to reach out to Qingpei from Allied, and I think they will be able to help you on that. And I think there is one question on the changing of validity of the cert. No, you have to generate your own certificate. You can change the validity if you generate your own cert, and you can define how long you want the certificate to expire. Right. Yeah, so that's pretty much it. I will now hand over to Jonathan actually to talk about the Stratus solution.
Thank you, Sung Yang. Hi, this is Jonathan. Let me share my screen. Gotcha.
Yeah, Jonathan is is our partner from Stratus.
Okay. Thank you, Qingpei. Can you help me enable screen sharing for my side? Okay. All right. Are you seeing my presentation slides right now?
can see your slide, but I think you need to change it to like a full screen slide.
All right, is this better?
Oh yes.
Okay, great. Thank you so much, everyone. I'm just going to bring you through Stratus and the KEPWARE synergy. So my name is Jonathan Chin. I'm the Regional Sales Manager for Singapore, Brunei, Philippines, Pakistan, and India. So a little bit of updates on Stratus. We have been with KEPWARE as a connected technology partner for almost the past 10 years. So you can see us in the website, in the KEPWARE.com, and you see that there is Stratus there as well. So without further ado, let me bring you an introduction. Who is Stratus? We built the most reliable edge computing system. So we're kind of really big at edge in terms of water. Some of the examples we treat, our platforms are being involved in systems that treat 197 billion gallons of water annually. About transportation-wise, 1.5 billion passengers by air, by rail, 45 million, so on and so forth. So we've kind of been around for about 40 years in the business, and we have about 12,000 and counting active support customers. So those are customers that we proactively maintain and manage the systems for them. So our portfolio is really it only consists of three. So we first have our flagship model, the FT server, which is a 4U rack mount unit, very versatile, fully turnkey and customizable in terms of RAM, storage, PIC cards, PCI cards. And then we have VTC Edge, which is our edge computing platform, which is something that I'll introduce to you later on. It's industrialized, it comes virtualized with built-in fault tolerance. And then we have software, which provides a high availability and fault tolerant feature for a x86 conventional server system. So if you look at our key customers, these are a sampling. We're kind of diversified. So we started out in the finance industry with payment switches. We still serve them, customers like Citibank, American Express, UOB, and then we go on to other oil majors like ExxonMobil, Columbia Pipeline, Glencore, pharmaceuticals, to food and beverage. So we're kind of big in automation as well. So what essentially do we do? We prevent downtime before it occurs. So what we do in our solutions is that we enable rapid deployment of always-on infrastructure from enterprise servers to cloud without changes to your application. In short, it is actually simple, protected, and autonomous. So the system we provide does not have to be modified to a particular OS. Generally, we support the three big ones in the market: Windows, VM, and Red Hat. It is simple to manage, meaning to say that it sets up in minutes. It takes about typically less than an hour or half an hour. Easy to manage. It's a plug and play maintenance system. And there's a single button restore when you set up a new system or you have a backup somewhere and the whole system is down. All it takes is a single button to restore it. It is hardened. It is protected in terms that there is seamless failover. So we're not in the business of like having a failover system. We are talking about failure recovery, and with full stack protection, meaning to say from platform all the way to application, it is protected in our platform. Autonomous, meaning to say that you don't have to worry too much when there is a defect. The system self-monitors and heals itself. And when we talk about automated replacement, like I said earlier, it is a plug-and-play system. So when a system prompts you for alarm, it still runs and you can endure that fault. But all you need to do is get the replacement unit from us, plug it in, it auto-synchronizes and auto-replicates itself. And you can remotely manage this through cloud or on-premise as well. So that's our technology mantra generally. And really our vision in automation is really to be the premier edge computing specialist. Like I said earlier on, our platforms aim to be simple, protected, automated, and therein lies all your application software, which is generally what is happening in the market. Things like information management, optimization, OPC, AI, visualization, planning and scheduling, so on and so forth. Our platforms we have made it very, very simple to have high availability or fault tolerance built in with virtualization. So nowadays, the talk is really about improving productivity. People want it faster, better, and cheaper. And the way to do it really means you need to do more advanced computing at the edge, where you connect all your devices, your PLCs, at as close to the edge as possible for to get analysis and real-time data that can be easily used or more effectively used by the operators at the plant floor. The only problem is that with this thing called IT/OT convergence is that you have more and more technology that will deploy where there are fewer and fewer IT skills. So your production floor people, your process technicians or engineers, generally they know a lot about PLC. But when it comes to the IT part of things like servers, visualization, actually they, for the most part, they don't really get well trained on that part. Of course, again, when you have a difference in the IT/OT engineers, generally they don't have IT skills. Generally, the IT guy will always think that you can manage a downtime, apply patches at certain times, whereas in a process environment, there is no downtime, maybe a scheduled downtime every 2 years or 1 year or 5 years, and everything is real time. And there's an impact in terms of application downtime, be it a material cost, be it a revenue loss or a brand loss or production loss, there's always a cost involved. So that is why always on effectiveness really matters. Can you imagine a server that is down in the plant, and because of that server down, right, you then have an issue with production because you cannot monitor, there's no QC. Now, Stratus always on zone plays in that level where we provide as a minimum 99.999% availability. Doing the math, that equates to about 5.25 minutes per year. And if you do a dollar value cost, about 14,000. They're about based on the ARC consulting computing system. So in the market so far, when you talk about modern digital environment for protection, right? There's about a couple of solutions in the market. The first one is really where you say, hey, I just need redundancy. So the most easiest version is just to put 2 servers, one active server and one cold server. Now, what it does is that you have a single point of failure that causes downtime and data loss. And when you want to switch over to the next server, it has to be done manually with a lot of IT skills and effort. So that usually takes about 1 to 4 hours of service generally. Even worse when you're in a remote location. And then you go on to say, hey, why not just do clustering or virtualization, high availability or fault tolerance? But in both cases, you need a lot of extra hardware, like 2 sets or 3 sets with a SAN storage with extra switches. And then even then, we're not talking about fault tolerance. We're talking about high availability where you still need to write scripts. And there's still what we call failure over and there's failure recovery. Yeah, and all these needs some IT skills. So what Stratus does is that we made it very simple and protected autonomous. There's no single point of failure. It's simple to implement. Everything is out of the box, easy to service. And the most important thing is it is built just for failure prevention, not for failure recovery. No failover time. It's an instantaneous takeover. So that's where we really deploy our product. Really, we can serve all the way from level 1 to level 5 in the produce scale in the industrial plant. From batch, discrete, drives, process, SCADA, all the way to enterprise network. It really depends on your system. If it's going to be enterprise network, I would definitely propose a FC server because of the size of capacity required. But if you're really going down to the edge at the plant floor, then yes, a CTC, which is built for that purpose, is good enough. And I'll show you how in just a few minutes. And okay, just to tie it back to the general theme of this presentation, generally what we're talking about is that, of course, we have the KEPWARE server EX, which you already heard a lot from from Shenyang earlier on. It is actually a very powerful OPC protocol, OPC software and server that can help you connect, manage, monitor, and control. So that's actually very powerful, and it actually fits very well with the CTC Edge. So if you look at it, a comparison that I did, at least on a paper-wise, for the Windows operating system, for system requirements, 2 gig versus 2.4 gig, we have 32 GB or 64 GB or 2 TB SSD. Ethernet is more than enough. VMware and Hyper-V and all the rest of the IT standards are supported. And the reason why I actually propose the CTC for the KEPWARE OPC is really because very often, because I come from automation background as well, usually you install OPC in a single backup server. Now, when that server is down, the problem also occurs that you will need to get it restored. And during that period of time, you have a period where you have loss of control and loss of data. Or perhaps data not so, because you can back it up in another storage. But then again, during the time for repair, you have a lot of data. So here it is. Let me introduce the CTC Edge computing platform. So basically, it's a secure, rugged, highly automated computing platform that delivers reliable edge applications quickly and easily, improving productivity and reducing risk. So a couple of key features is that it has built-in virtualization. So it really supports Windows and Linux-based software. You can have OVA and OVF images. You can just download it into the system, and it allows you to, and that's all you really need, because everything is built in already. If you look at my management console, which I do not have at the moment, you can see that it's really a plug and play feature. So you can even update your applications without shutting down the system. You can determine which applications in your that are fault tolerant, required, mission critical, or high availability, or not critical as well. Next thing about the CTC Edge computing platform is that it has simplified security, meaning to say that you can actually have host or host-based firewall where you can whitelist or blacklist your system or your IP addresses. You can have role-based access, and in fact, even the USB that you see over here can be hardened so that you don't have the risk of where someone plugs in a USB that is not authorized and has a malicious software and malware on it. In terms of industrial interoperability, it works really through SNMP, REST API, and OPC. So it is really built as to function as an OPC platform as well. For OT manageability, it can integrate to the whole system of alarm management, and you can monitor from our dashboard the platform, the virtual machine, and the application system health and threshold. Whether it has exceeded the threshold or not, the platform actually updates you. So there's a couple of ways you can do it. Of course, this one I mentioned SNMP and REST API to integrate to your main alarm monitoring system. But you can also configure it to send an email or or a text message to your mobile phone as well when there is an alarm. But bear in mind, when there's an alarm and there's a system failure, right, it is fault tolerant. So the system will tell you an alarm, but the system is still running. So what it tells you is that you need to prepare for a spare part and then get it replaced. And the replacement of the spare part is pretty simple, which I'll show it to you later on. It comes rugged with redundant nodes. So even when you purchase a fault-tolerant CTC system, you purchase a pair. Yeah, so everything is DMR. It is, and it also has high heat and vibration tolerance. Okay. So the thing it is that it has automated protection. Like I said earlier on, it automatically oscillates faults and reroutes data and application for full functionality uninterrupted. So the system, right, it's a DMR version. On it sits a virtualization layer. So when there's a fault, let's say node A or node B, all your systems on node A will automatically be rerouted. Actually, it's all been synchronized in the background all this time. So when node A goes down, automatically node B takes up, and your applications will run without interruption at all. Okay, so the beautiful thing also is that you don't need to do additional scripting. You don't need to add additional hardware or cluster because fault tolerance is already built in out of the box here. So in terms of serviceability in the field, the nodes can be replaced by non-IT personnel. It's basically a plug and play system. Say node B is down, take out node B, we give you a new node, put it back, plug in the system, it will auto-synchronize and auto-recognize it, and you don't need to do anything. All the while, during this repair and replacement, the software, the system is still running. This is a graphical view of how it looks like from the front. You see there's about 6 GB, 6 times 1 GB port, and two SSD ports in front as well. And there's the back view. You notice that the A1 and A2, that is for your interlink between the two nodes, and your power plug as well, your power in as well. Okay, this is how it looks like when you put it into the automation cabinet. And we make it very rugged. If you can look at the 100i and 110i data sheet, basically it's an i7 chipset with 6 core, memory-wise about 32 to 64, storage 2 TB, more than enough. Temperature, depending on the platform you use, it can go up to about 55 degrees, heat tolerance. The shock and vibration is about 50 G, 11 milliseconds. So technically, you can put it near a compressor or a turbine or into the cabinet that houses your PLC for a compressor and turbine. And that's okay because it's built to put in that way as well. It's built to survive in those kind of conditions. Dimensions are pretty small. So we're looking at a laptop size IPC or edge computing platform, just a little thicker, about 3 inch to about 3 inches tall. Weight-wise, it's pretty small. Beautiful thing also is that the TTC 110i is certified all the way up to Class 1 DIS 2. So it's actually suitable for hazardous locations and environments as well. Yes. So this is how it works. Theory of operations. I mentioned earlier you can customize availability, and this is how you connect the system. So private network connects the two systems for synchronization together of application and data. And then you have production networks where your PLCs are, your instruments are, and it goes up to the node 1 and node 2, and on top of that is where the applications sit on. So I put in 2 different applications here, App A and App B. App A is a high availability system, and App B is your fault tolerance system. So a fault tolerance system, where you define it as such, both the memory and data are actively synced, so that whenever one fails, one of the nodes fails, instantly the other one takes over. Now App A, right? If you notice, one App A wording is on the left, which is active, and the other one is on the right, which is passive. That is high availability. And how high availability works is when there is an active and a passive server. So when active server is down, only then will the passive server start up. And that period when the passive server starts up and it detects a failure of heartbeat is what we call failover time. And that could cost up to like seconds or a few minutes. It's like it's basically your CPU booting up. So that is the difference between HA and FT. And now that CTC, right, you can define the application to be either fault tolerance, high availability, or not critical. And all those things means you can actually define your resource management, because fault tolerance will take up to bigger resource, high availability, lesser resource, and non-fault tolerance, of course, a lesser resource required. You can even split the nodes up into 2 different buildings for disaster recovery. So, and all you need is just basically to have a 10 GB throughput. The network has to be 10 GB throughput from both sides, connected peer-to-peer. And you need to make sure that it has 2 millisecond round-trip latency. Correct. And so that is how the CTC system works. It can work together as a pair in the same automation cabinet, or you can split it apart, put it in another building through fiber optic, as long as the throughput and latency are there, and then you have a disaster recovery out of the box without any other extra software or hardware or scripting to be done. So from a services viewpoint, you then have things like we have two-tier structure, and the first tier is really a very reactive system. So we give you things like software updates, secure access to service portal, 24/7 web and phone support with 30 minutes critical response. Now, what is unique in this two-tier is that we have this thing called advanced parts exchange. So what it does is that we proactively give you, let's say there's a default, there's a defect, and there's an error that comes up that demands a replacement. What we don't do is that we don't send you a motherboard to replace and then you do it yourself. In this agreement, we send you the next business day one whole actual node, and your guys, production technician that is not IT trained, can go up to the site, take out the old one, put the new one in, and you auto synchronize. You don't even need to switch it on. It will recognize the power going in, and then you auto synchronize the data, and then it will continue running. And all the while, you don't need to down the system or do any technical scripting skills. Now, when we talk about the next tier, which is a system health, that is where we actually proactively monitor the system for you, where we do things like 24/7 remote health monitoring in your system. Should you allow us to, we do log file review, we do predictive failure analysis, and media retention. So basically what system health does is that we do more for you and free up your time to focus on other value-added activities. Beautiful thing about this, currently, we don't have a product end of sale officially announced. So generally, the system has a more than 5 years product life cycle at this stage. So even when there is a product end of sale announced, which hasn't happened yet, you still have about at least 5 years upon purchase. So what's the value propositioning when we talk about KEPWARE, EX7NX, and the Stratus CPC? When you talk about redundancy and fault tolerance and HA, usually you want to have 2 hardwares and 2 application licenses to effect a high ability system. In this case, now it will be 1 application licenses and OS required. In a fault tolerance system, there is no data loss guarantee, allowing for accurate real-time analysis. It's really a one-stop system for compute and storage protected by our inbuilt fault tolerance features. Easy deployment, it's under an hour. Everything is out of the box. You don't need to do additional hardware or software or scripting, so that reduces your engineering hours, your FAT and SAT time, and kind of reduces the footprint because you can then put this server into your automation cabinet as well, and reduce your power and storage costs. Now, the last thing, of course, really is that it gives your IT guys, right, or rather a break. Your OT guys can manage this because it is easy to use and easy to maintain. It is a plug-and-play system. All right. So that is really what I come here to present at this point of time. I have a Stratus digital project pack that you can scan and get more information. But if you have any other questions at this stage, you can ask them now.